Hi, I'm Darren O'Leary, Managing Director of Restore Subsea. Our sole purpose is to enable the efficient and safe removal of subsea oil and gas facilities and biohazards from the world's oceans by developing solutions that seamlessly integrate into existing supply chains. DISR recently published an Australian decom liability report, advising that Australian operators face a $21 to $87 billion liability to clean up their subsea licences. The base case requires complete removal of all subsea rigid pipelines. Shareholders have limited insight, and Australian taxpayers could be on the hook for a majority of these costs. DISR's report considered subsea cut and lift as the preferred solution for removal of subsea rigid pipelines, because it is more comprehensively understood from a technical perspective. Thailand has been a global leader, removing their current 300-kilometre backlog in 2022 to 2023 via DP pipelay vessels. This involved reverse Xlay into 40-foot joints, while capturing all internal pipe fluids on board for onshore treatment, with an average offshore removal rate of 1.2 kilometres per day. Australia has removed the first 30 kilometres in 2023 to 2024 via subsea cut and lift of 40-foot to 80-foot joints via a DP CSV. The removal rate was lower than Thailand without the ability to capture internal pipe fluids. We estimate that recent Australian regulatory policies will result in a backlog of 888 kilometres of subsea rigid pipelines, requiring removal by circa 2030 for a minimum cost of $1.8 billion using current solutions. We also forecast the global cost of subsea rigid pipeline removal to be $38 billion by 2040. New solutions are clearly required to significantly reduce costs and increase sustainability. Xlay is a reverse Xlay solution with some novel and counterintuitive steps. It requires pipelines to be plastically strained in a pre-engineered and controlled manner from the seabed to the surface prior to retrieval. This enables lower-cost vessels with much longer open decks to achieve much higher productivity rates than traditional pipelay vessels, resulting in greater than 50% cost reductions. We have been preparing and engaging with key contractor, operator, and government stakeholders for several years now. We also have patents granted and pending, and our goal is to be DNV qualified to suit this 880-kilometre range of Australian pipelines and similar pipelines globally by Q4 2026. The following simulation outlines how Xlay could be applied to the 2030 pipeline removal scope in 2 campaigns. For Campaign 1, Eastern Navigation's hookup and commissioning barge, the WB 400, would remove the first 275 kilometres of pipelines extending from the shore to 15 metres of water depth. Eastern Navigation Singapore is a major seed investor in Restore Subsea, and the WB 400 was previously hired by Bhagwan Marine to remove the Chevron Thevenard Island platforms in 2024 and 2025. An Xlay system would be engineered and licensed by Restore Subsea for a contractor to procure, test and mobilise it to the WB 400. The complete system, secured to the deck of this 8-point moored barge, draws on well-proven industry-standard engineering and equipment. The primary novel element that requires further R&D is the engineering and modelling of the safe limits of pipe tension and allowable plastic strain for the operator-specific pipelines to be removed. Each pipeline would have been modelled in detail, including an assessment of the current state of integrity from intelligent pigging and other such data to ensure the pipe tension, stinger configuration and other parameters are optimal. Each pipeline will have been pre-flushed and sealed at both ends. A deburial campaign would also have been completed, potentially via the same vessel with the Xlay system in standby mode. This particular Xlay system applies an external water blast prior to running each pipeline through a straightener and 2 tensioners, before being cut and stacked into 160-foot pipe joint lengths. All internal fluids are also captured for temporary storage. The 160-foot joint lengths would be bundled and offloaded to a cargo barge alongside. The internal pipe fluids would be discharged to the cargo barge alongside. Once full, all pipe associated materials and fluids would be transported to shore for handover to the onshore disposal contractor. Shown here is a DP CSV of similar size to the WB400 barge. For Campaign 2, it would remove the balance of pipelines from 15 metres to 80 metres of water depth, utilising the same Xlay system from Campaign 1 with a few minor modifications. It would also retrieve 160-foot joints, but rather than offloading to a cargo barge, it would lay down the pipe end and return to shore when full. Another option for Campaign 2 is to use a DP wind farm vessel as shown. These vessels have extra long decks as shown relative to WB400 and can retrieve 400-foot joints at extremely high productivity rates. This may become a very attractive option given the potential looming weak demand for such vessels in the offshore wind market. Visit us at restoresubsea.com to learn more about how Xlay can significantly reduce decommissioning costs.